Each piece of candy in a store costs a whole number of cents. Casper has exactly enough money to buy either 12 pieces of red candy, 14 pieces of green candy, 15 pieces of blue candy, or N pieces of purple candy. A piece of purple candy costs 20 cents. What is the smallest possible value of N? Okay, so first I'm just going to keep track of all this stuff. So he can buy 12 pieces of red candy, 14 green, 15 blue, and N pieces of purple candy. I also know that, let's just say that this R, G, B, P, those are the prices of the candy. So let's just say we know that P equals 20. So the total amount he spends on candy is 12 times R, 14 times G, 15 times B. And since he has exactly enough to buy 12 times R, 14 times G, it's got to be true that, since I already know that, it's got to be true that 12R equals 14G equals 15B and equals N times P. I was told that P is equal to 20, so it'll be 20 times N. Okay. So the smallest possible value of N. So the way we're going to do this, I'm just going to test out the value. So let's just say first that N is 18. So I'm going to look at 12 times R, 14 times G, 15 times B. And I'm first just going to see if factors of 15, 14, and 12 go into 20 times 18. So first I'm going to check the 15. Well, 15 is just 5 times 3. There is a 5 times 3 and 20 times 18, so that'll work. 14 times G, that has a 7 in it. And looking at 20 times 18, there's no 7 there. 7 is not a factor of 20. 7 is not a factor of 18. So because of that, 18 is not the smallest possible value of N. So next, let's look at 21. So 20 times 21 equals 12R equals 14G equals 15B. So again, there is a 5 and a 3 in 20 times 21. So that checks out. 21 is 7 times 3. So there is a 7 there, and then 2 is obviously a factor of 20. So 7 and a 2, yep, that's in 20 times 21. And then 12, 4 times 3, there's a 3 in the 21, and then a 4 in the 20, so that checks out. So therefore, 21 is the smallest possible value of N. So the answer is B.